All right, hello, welcome to this training. So in this training, we want to look at the impact of time upon the various hashing algorithms. So we have various hash algorithms and we want to look at what is the time that is required to compute each of the hashes. So we're going to have files, a list of files in here. We have four files is right here, and we are going to use about four algorithms here to compute the hash and look at the time that is taken for each of them. Then we look at which one has the highest computational time that is required. So we can pick this file here and then we can start and then look at the time. So this is going to be the real time that we're going to take. Real time is a summation of what is the time that I input as the user looking for this, and then what is the return of the system time. So the summation of this gives us the real time. So based on this, we can repeat the same command several times. Then I take time some more just to get its values, and then over this inside this Excel, what we have is to have done it for various file sizes. So we have different file sizes and we are going to compute the MD5, the SHA-3, 256, 512, and SHA-384 for the various hashes. We'll be taking 10, we're taking trials for MD5, 10 trials for each of them, and after that we'll compute the mean. So this provides the various real times that we had based on what we discussed over here, and then after we compute the mean. So the mean value is nothing else than the summation of all the 10 points and then the 10 timestamps and then dividing basically by 10 to provide the mean. So based on this, we graph it, and then clearly we can tell that from here, if we take for example MD5, as we can clearly see that as the size of the file increases, the time required to compute the MD5 hash also increases linearly. So you can see at 20 meg we were doing almost around 0.16 seconds that took. At 40 the size begins to increase. At 60 is 0.27, at 80 is like that, and at 40 like that. Then we can also clearly see that this is happening the same way for the various SHA, the SHA-3256, SHA-384, 512. They all increase linearly as the file of the size, the file of the size also increases like that. Then another comparison we can easily draw is to compare the various hash algorithms with the same file size, and that we also see that it increased. So if I have 20 meg, the time required for MD5 to compute 20 meg is shorter because it's only giving us 128 bit space computational. Whereas 256 the time required is higher than MD5, and then similarly SHA-384 is also higher than the 256 and higher than the MD5, whereas SHA-3512 will definitely take a more time to compute for a 20 MBP file compared to these file sizes. So we can clearly see the difference as well. In 40 Mbps, we can also see the varying difference as it increases in that order, and 60 Mbps we can see, 80 Mbps we can also see, and 100 Mbps we can also see like that. So we can clearly see that if you have a SHA-512, the time that will be required to compute will definitely be higher. So here we've gone through the graph, and in the conclusion we can see that the execution time basically varies with the input file size. That is, as the size of the file increases, the time taken by the hash algorithm to compute the hash also increases linearly, and that is clearly what we see. And then also for each size of the file, the execution time per algorithm also increase linear, and that is, if you have 20 Mbps, the execution time for MD5 is lower compared to 256 and 384, and that also increases linear like that. So we did a couple of comparisons here. For example, if we want to compare MD5 time taken for MD5 to compute compared to this, we can clearly see that SHA-3256 requires more computing time than MD5. Similarly, SHA-384 also requires more computing time than the MD5, and then that also requires more computing time than the MD5. So we are clearly see that they increase linearly, and then also SHA-256 compared to SHA-384, we clearly see that 256 any of them, you can see that the trade for computing power also increases, and this is simply because of the size space that is going to the hash space that is going to go. This needs to output 384, whereas this will go 512, so it requires more time to hash to 512 bits as compared to 384. So clearly we have seen the relationship with all these as the file size basically increases. So in a summary, as the file size increases, the computational time required for each algorithm also increases linearly, and then also per file size you can clearly see that each algorithm also increases linearly from the MD5, which is 128 space hash algorithm, whereas SHA-3 is 256 space hash algorithm. This 384 and this 512 also increases algorithm. So that's all for this video. Thank you very much for joining, and then bless you. Bye.